On some problems in the UIL Number Sense contest, you're going to be asked the number of integers relatively prime to a specified number, and they're usually going to give you a range, okay? So if you're doing this, first of all, what is relatively prime? Well, two numbers are relatively prime if one is the only factor they have in common. And that means that one is relatively prime to every single number out there because it only shares one as a factor. So let's look at some examples. So 2 and 9 are relatively prime because the factors of 2 are 1 and 2, and the factors of 9 are 1 and 3. Only one is in common. But 6 and 9 are not relatively prime because 1 and 3 are factors for both of them. All right, so if you get the question, how many are relatively prime, then how can we do this? So first of all, we're going to do a very concrete example. This is not what you're really going to do on the contest because this takes too long. We're going to look at the number of how many numbers from 1 to 30 or integers are relatively prime to 30. So this could take a while, right? First of all, let's list out all the factors of 30. They're 1, 2, 3, 5, 6, 10, 15, and 30. So those are relatively composite. But those aren't the only ones that are relatively composite. So we could go through all the numbers and cross off the relatively composite numbers. So first of all, 1 is relatively prime, so I'm not going to worry about that one. But 2 is a factor of 1 and 30, so I got to cross off 2. But guess what? 2 is also a factor of 4, 6, 8. So I'm just going to cross out all the evens. Okay, those are all relatively composite to 30. Then I can go and look at multiples of 3 that are not already crossed out. And you can see 1, 2, 3, 4, 5. So we crossed off 5 more numbers that weren't already crossed out. There were a total of 10 that are multiples of 3. And then we can cross off all the numbers that are multiples of 5. Don't have to do 6 or 10 or 15 or 30 because those were already crossed out when we did 2, 3, and 5. So if we look, we have 8 numbers left over that are relatively prime to 30, that are between the range of 1 and 30. All right, that's a lot to do, but there's a faster way. So let's look again at what we were doing and how could we do this more mathy, right? So first of all, we're still going to do the prime factorization, and we're still going to take away the multiples like we just did. But this time, what we're going to do is 2 is the first factor of 30, so we're going to take away every second number or half, right? So there are 15 numbers left, all right? And then 3 is a third factor, so we're going to take away every third number, all right? So that leaves 10, okay? And then finally, 5 is the third factor. We're going to take away every fifth number, so we're taking away 2, and that leaves 8. Now we can shorten this even further. So instead of taking away in steps, we're going to find out how many are left. So the first prime factor is 2. So if we take away the evens, then half are left, right? So we go 30 times a half is 50. All right. Second prime factor is 3. So we're going to take away a third. So a third of the 15, or sorry, we're going to take away a third. So how much is left? 2/3. So 2/3 of 15 is 10. And then last prime factor is 5. So we're going to take a fifth away. So how many are going to be left? 4/5 are going to be left. So we get 8. So you can combine this all in one step. You just take your number and you take your prime factorization, right? And the top number, because you're always subtracting from 1, is going to be, you're going to change it to a whole to be P1 over P1. You're going to be 1 lower than your prime on top. So for 2, it's 1. For 3, it's 2. For 5, it's 4. All right? So we can just combine this all in one step. So we have 30 with the odds left over times 2/3, which are the non-multiples of 3 left over, and then 4/5, which are the non-multiples of 5 that are left over. So if we multiply that out, and you can even see that you can simplify a little bit there. Here we go. You can see that the 2's go away. So you have, and then you can say 10 times 4/5, that's 8. So that's your shortcut for finding the number of relatively prime integers in a specified range.